Hello there, my name is Peter and this is in fact the first video for a channel I call The Bleeding Edge of Fornicating About. It's a small change in wording to keep my editor happy. I'm an almost retired software engineer who's looking for interesting ways to keep himself off the streets when retirement strikes. Part of that will be spent working on private projects I hardly ever got to work on while I was working a full-time job. A substantial part of it will be spent lazing about, possibly with bass guitars, motorcycles, my wife, cats. And another part will be explaining some of the stuff that I learned during my career. I've apparently always had a knack for explaining things in a non-complicating manner, as I discovered when, decades ago, I explained to my mother how a single lens reflex camera with automatic exposure worked, and she actually got it. Some of that will be directly related to writing code and making software, and some of that will be more generic, such as how to survive and get things done in a business environment, and which traps to avoid like the plague. The first concept I'd like to talk about is polymorphism in .NET software development. I'll do that in a series of videos, of which this is the first one, and I'd like to start off with inheritance, which is one of the underlying concepts of polymorphism. It's one of those $25 words that, when you understand what it does and what it can do for us and how to work it, it suddenly becomes a lot less vague and wordy and opaque, if you will. And unless you run away from me now, understand it, you will. Yes, channeling my inner Yoda here. Mind you, we're not going to talk about multiple inheritance here. We'll briefly touch it, mainly to explain why modern programming languages like Java and C# steer clear of it. Multiple inheritance, as supported in C++, is generally unnecessary, and it's also an excellent way of shooting yourself in the foot. Or rather, more like blowing your whole leg off, as will be explained later on. Polymorphism in software development is regularly presented as rocket science. A year or so ago I heard from someone who had actually successfully graduated in computer science at HBO level, that's computer science 1 level below university in this country, that they had no idea what the concept actually meant. And looking at the material they got, I kind of understood why. But it isn't rocket science, and I intend to make that clear for you, because it can be very useful for us if properly applied. So, without further ado, polymorphism at the bleeding edge of f***ing about. I'll probably have to bleep that out. First of all, we will want to dissect the $25 term polymorphism into something every one of us can understand. So let's grab a dictionary. L O P No. Ah, yes. There we have it. Polymorphism is the ability to assume different forms or shapes. Yeah, that's not helpful. Alright. Okay, let's illustrate that with an example. Many a helpful example of polymorphism comes from biology, which is where we developers stole the concept of polymorphism from to begin with. It's called sexual dimorphism, which refers to two biological genders, female and male, which are two different manifestations of a genus, sort of animal, and this in fact applies to most animals. Now, before we get into a discussion about gender fluidity or non-binary self-identification, I fully acknowledge that these are real phenomena, but we're dealing with the general concepts here, not the outliers. With some animals, you'll have a hard time distinguishing between males and females, whereas with other animals the distinction is so in your face that you would not even believe these are the same species. The anglerfish, which we show here above, the female and the male, is a good example. So, with that out of the way, let's assume that mammals pee. This may formally not be true, I don't know how it works with dolphins, but for now let's just assume that they do. In some species, males and females pee differently. Take dogs, or humans even. So within a species, you could need two implementations of the method pee, brackets. One requiring the dog to stand, lift a hind leg, aim for the tree or another vertical object and let go. Females, who are generally smarter, have a much simpler implementation. They squat and let go. If you're unfamiliar with how dogs pee, say for instance you're a cat person, feel free to take the human species as an example. That should make things clear. And there you have it, an example of polymorphism we can actually demonstrate in Visual Studio, which is precisely what we'll be doing in the second video. There are two concepts usually associated with polymorphism. Will you shut up when I'm recording a video? Right. Where was I? Yes, there's two concepts usually associated with polymorphism: inheritance and interfaces. The concept of generics also comes into play somewhere, but we'll cover that separately in the foreseeable future. I foresee. The concepts of inheritance and interfaces are closely related. They both contribute to the concept of polymorphism in Java and C#, but they are distinctly different. Inheritance is the ability of a class to inherit functionality from another class, sharing its public properties and methods. This is particularly useful for classes that are related. A circle and a rectangle are both shapes, an apple and a lemon are both fruits, a tow truck and a motorcycle are both transportation vehicles. An interface, on the other hand, is a way to define a contract that an implementing class will have to adhere to, providing its own implementation of the behavior specified in the interface. So what is that in English? Well, the interface tells the class what to do without telling the class how to do it. Interfaces are quite good at tying less closely related classes together. An example: interfaces are a good way to tell unrelated species to implement their methods for the 4 F's. That's also a concept from evolutionary biology: fighting, fleeing, feeding, and mating. But they'll have to sort out how to do this themselves. So, let's start out with inheritance then. Because I also want to show you some diagrams, I have, for the first time in my life, no, for the first time in years, yes, created a PowerPoint presentation, which I'm going to share with you now. Now this should be a good take. I want to clarify a few concepts before we actually get to code, which is why, for the first time in years, I actually created a PowerPoint presentation. But don't worry, it won't take long. Um, what I want to show you is the phases of inheritance and how that applies to us in object-oriented development, specifically when using Java or C#. So, inheritance basics. This is actually all you need to know about how inheritance works conceptually. And let me explain that to you. Here we have a base class. The base class has a property, a public property name, and the base class has a public method called foo. There will be a derived class. That's a class that inherits from the base class, and it will have its own public method called bar. And we can have a second derived class, which also inherits the base class. That's why it's derived. And it has its own method called do something. Both the derived classes 1 and 2 get their own instance of the class they inherit, which is the base class. And they also get access to the properties and the methods that are in that base class. So our derived class 1 will have its own public void bar method, but it will also have access to the name property, and it will have access to the foo method. For the second derived class, base class, this will have access to the name and foo property of the base class, but it will have its own public method do something. So, how does that look when we're going to work with it? Well, here we have my code. I instantiate a new object of type derived class 1. We call it Flutter. We use the name property directly from the derived class that we instantiated. So we have flutter.name and we have flutter.foo. Even though the derived class 1 doesn't have these properties and methods internally, they get them from the class they inherit, which is the base class. So the same thing goes when we instantiate a new instance of derived class 2, which we call blurr. Blurr also has access to the name property and the foo method, and blurr can use its own do something method. Please note two things. First of all, both Flutter and Blur get their own instance of the base class. So if we set Blur name to Jane Doe, our Flutter name will still remain John Doe, which is what you'd expect from .NET Framework anyway. And the second thing I want you to note is that Blurry, which is the derived class 2, does not have access to a bar method, because the bar method is a component of derived class 1 and it is not exposed through the base class. This is how it works. So, what concepts do we come across in the literature when it comes to inheritance? The first one is the concept of single inheritance. This has a base class and one derived class. Quite frankly, I can't think of a useful example of single inheritance, and I don't think I've ever seen one in everyday life. Go ahead, prove me wrong in the comments if you want. So, the second concept we want to examine is the concept of hierarchical inheritance. This is a base class which has two or more derived classes dangling under it. I'm not sure why this is called hierarchical inheritance. Single inheritance looks just as hierarchical to me. Now, we can also stack or cascade, if you will, classes on top of each other. This is called multi-level inheritance, and it means that we have a base class which is available to derived class 1, and then we have derived class 2, which does not inherit base class directly, it inherits derived class 1. This means, of course, that everything that is in derived class 1, including the stuff that derived class 1 gets from its base class, are also available to derived class 2. Now, the hierarchical inheritance model and the multi-level inheritance model are both very useful, and we are going to see both of them at work in the code exercise, which we are going to do later. So, we also have forms of multiple inheritance, and you can see by the nasty looking devil that we do not like this. So these inheritance patterns are strictly avoided in .NET and Java. The reason why they are avoided will be explained in the next sheet, or at least some of those reasons. We have the first form of multiple inheritance, which is called, would you believe it, multiple inheritance. This means we have two base classes and we have one derived class which inherits both base classes. We also have a concept that is called hybrid inheritance. This looks like one base class which has two derived classes which inherits the base class. And here it comes. There is one derived class that doesn't inherit the base class, but it inherits derived classes 1 and derived class 2. Why is multiple inheritance generally avoided? At least in C# and Java. Well, the main reason is it adds a lot of complexity. I will give you an example, which is called the diamond problem. In this problem, we have a base class, and it has, for instance, a property of type color, which is called color. Now we are going to create two derived classes, derived class 1 and derived class 2. They both have a method called foo. Derived class 1 dot foo sets the color to red, and derived class 2 dot foo sets the color to green. At this point, you should probably get an inclination of what we are going to face. Indeed, we have a derived class. This derived class inherits from derived class 1 and derived class 2. And what will happen if we get to use this code? Well, let's give you an example. Here we instantiate a new derived class 3, we call it Flurry, and we call the Flurry foo method. Which Flurry foo method? The one it gets from derived class 1 or the one it gets from derived class 2? Well, none of the above. You see, this is one of the things you can run into when you use multiple inheritance. Now, I should say at this point that it's not entirely true, but in general it is. C++ and Python, which are two languages that actually support multiple inheritance, they have their own mechanism of prioritizing derived classes over one another, including the methods that are in those classes. But still, you should be treated with care. I mean, the complexity caused by multiple inheritance increases exponentially with the size of the project. I mean, if you're working on a Hello World project, you will probably not get bitten by this. If the project gets a bit bigger, then it becomes harder to spot those issues. Now, one seasoned developer who is working on his own project and who is working on his own project continuously and not shelves it for half a year and forgets everything about it and then takes it back up. This one seasoned developer will probably get away with it, definitely. But if you're joining a team with multiple developers and the project they're working on is more or less of enterprise type size, and you are supposed to work on code written by developers who have left the team or even the company years ago, there is a large chance that you'll find yourself in deep multiple inheritance shit. And this is why Java decided to, let's not go there, and why C Sharp, which is essentially Java but on steroids, followed that same route.